All right, guys, I finally got some screen recording software, and so now you can hear me ramble for a few minutes about the Nucleus software. So basically what we've got the two nodes just sitting on my desk, just kind of for demo purposes. We'll just kind of walk through this. Normally you'd be seeing this on your phone. I've just got it pulled up on my PC here. Of course, so we'll just start from the top. Logo, this is the IP address of this node. So all the routing's done via Babel and SMC route. So it's all IP based instead of layer 2 like the guys using Batman get. Anyway, so mesh indicator up down, just telling you the Wi-Fi mesh is up. There's some data on it. It continually tracks the congestion on the channel that you're on. If this starts getting bad, you can always change channel. And here, in this case, you've only got one node, but obviously as you have more, it'll list the IP address for each node. It gives you a raw signal indicator and then a link metric from Babel. The link indicator, the raw link indicator, is not super easy to read. So we just assigned a percentage to it to make it a little bit easier. And since this is a dual radio node, you also get the Meshtastic information. If you have the Meshtastic radio, talking to the node itself, you can run the Meshtastic radio all on its own. But if it's running as intended, connected to the node via serial, this will also show all of the Meshtastic nodes that it's connected to. Let you know the bridge is on, whatever. You got a shutdown button, so you can turn this thing off without just yanking the battery. All right, tools and settings. So this is kind of you got to do this. New edition. We've got a couple of methods now for hardware push-to-talk, specifically from, quote-unquote tactical headsets. It can also pull audio directly from the phone. The Nucleus hardware is going to be changing a little bit to integrate this, so I'm not going to dive into this right now, but just know this is here and functional. A monitor page. This just gives you some more detailed metrics on connected nodes. Obviously, as you have more nodes, you get more cards. It pulls some more of the in-depth Wi-Fi metrics out of IW and Babel. Let's see here. Config. So this lets you do obviously some config changes kind of on the fly. Mesh name, channel. This was kind of important. On the first page, if your congestion's getting bad, you can scan the 2.4 gigahertz channels. We'll get to that page later. And then pick the one with the least congestion. Passwords, access point, channel, passwords, etc. Let's see. Wi-Fi scan. Okay, this is the one I was telling you about. So this can flip the 2.4 gigahertz radio into a kind of a scan mode. It'll run through and listen to all the available channels, give you an idea of which one's the least congested. So that can be changed if you're having congestion issues. Remote. This controls the tailscale instance, gives you your tailscale IP, what tailnet you're connected to, turn it on, turn it off, switch tailnets. Just kind of bringing some of that functionality out of the command line to the web interface. Network. This gives you, your various IP addresses for your different interfaces. Ethernet. In this case, I'm plugged into my home Wi-Fi, home router. So I got IP addresses from there. The LAN, that's a static IP. Tailscale. This is from the Tailscale instance you saw on the last screen. This lets you flip Ethernet modes. Generally, we'll leave it here just so we can pull a IP address. From a DHCP server. If you were out in the field and wanted to connect some random device into the mesh, laptop or something, you'd flip it to LAN mode. That'll turn this into it'll activate a DHCP server on the Ethernet port. So you can plug stuff into it. It'll give an IP address to that device, and then that device will have access to the mesh. And There's some kind of description down here. OpenDHC. So this is really to support this jamming application. So this does video over IP, voice over IP, texting, just kind of a good general communications application. The big deal with this one is there's no centralized server. So each one of these runs this open distributed hash table Docker container, and they're pre-programmed. So when you buy a group of nodes, they all know to talk to each other, and they will synchronize, I guess, their hash tables. So it lets you do video over IP or whatever without any kind of central server being required. So as long as two nodes can see each other, you've got voice over IP, video, whatever. Instead of something like Mumble, where you need a central server to do something like that. Meshtastic. So this is kind of a fun one. So you can either, if this cursor on target bridge is off, then the Meshtastic radio acts just like your normal Meshtastic radio, advertises on Bluetooth. You talk to it through the official application, just like everybody's super used to. You can use it with ATAC, if you have the ATAC plugin on your phone. The way this runs by default with the bridge on, all of that is taken care of by the Nucleus itself. You've got a serial connection to the LoRa radio with ATAC running. There's a service that the TAC packet, SCK, whatever, that intercepts incoming and outgoing cursor on target packets, parses them, compresses them, shoots them out over the LoRa radio. So it'll let your ATAC instance run on both the Wi-Fi and the LoRa simultaneously, but it's also smart enough to, if a packet is picked up on Wi-Fi and then shows up on LoRa, it'll just dump the LoRa one. But what it does give you is a seamless fallback. So, Wi-Fi is going to be relatively short range, high speed. When that drops, you don't lose your ATAC connection. There's no break in connectivity. This LoRa radio has been running in parallel the whole time, and then you just seamlessly flip over to the LoRa connection. Each node has a reticulum transport instance running on it. It is doing two things. You've got all the default interfaces. One, it's running a TCP server. So this means, your phone or whatever, you can point it at this interface, and that'll give you connections to any other reticulum device on the mesh network. And it also, because this is configured as a transport instance, gives you connection if you've got internet backhaul to a public IP-based reticulum connection. So as you can see here, pushed out to the internet, they've got 7,000 something destinations available just via plugging into this node. Mesh peers, this is just pointing you at the other Wi-Fi connection, just saying that, hey, there's another reticulum device over here. Let's see, we're just about at the end here. Reticulum. So if you've got OpenTAC server installed, I don't do that by default anymore just because of how expensive RAM's gotten. This is kind of the RAM hog of the system. If you don't have this, you can go on a lot cheaper hardware. But if you've got it installed, this page will be available. Just a super simple status, and it can push you directly to the admin page as needed. And last one, I just made we've got a little path trace tool, so as you have more nodes, it'll obviously populate out. But what this will do is let you see the path that your device is taking to connect to the target device. So, like in this case, we're directly connected. Obviously, they're sitting on the desk beside each other. If if you had nodes in between, it would show the hopping behavior to reach that node. Then it's got some kind of the raw data here. I think that's it. Yeah, so that's just a rundown, kind of long form, a little rambly of the operating system. This is kind of always slightly in work, and then with any luck, we'll have a little more in-depth rundown into this push-to-talk once the hardware gets finalized.